All right, super excited to be talking in the Cloud Native University. Like the previous talk mentioned, paid forward. Thus, I'm here sharing about my learnings and my journey and through the Cluster API and all throughout the Cloud Native stuff. There's a lot of stuff in Cloud Native. So I'm Jussi. I'm a senior principal engineer at Mirantis, where we leverage Cluster API to the core of it. We build stuff on top of Cluster API, and I wanted to take this opportunity to help you figure out what Cluster API is and how you could utilize it too. So yeah, we are actually talking about using Kubernetes to manage other Kubernetes clusters. Whether that's a good or bad idea, I'll let you be the judge. So Cluster API is one of the Kubernetes sub-projects. It really focuses on providing a declarative API to manage other Kubernetes clusters. So giving a declarative way, an API to manage Kubernetes, it really helps you provisioning, upgrading, and operating the full life cycle of the cluster or clusters. This is an example from the Cluster API book, which is the kind of authority documentation of Cluster API, so definitely look that up. But before we actually dive in what Cluster API is, I think we need to kind of think that why do we need, or do we actually need Cluster API? One of the challenges managing clusters, I mean, yeah, if you have like one or two clusters to manage, you can do it pretty much any way. You can do bash scripting, you can use Terraform, whatever. But especially if you're looking into managing multiple clusters on multiple different infrastructure providers, multiple different cloud providers, things get spicy very quickly. Because different environments probably require to use different set of tools, at least different flavors of the tools, and you get this kind of what we call cluster sprawl in a way. So with Cluster API, the main goal really is to get a centralized place and a centralized way to manage your clusters. Just like with Kubernetes. We want to have a centralized way and centralized place how we manage our workloads. And that's the Kubernetes API and Kubernetes cluster. All right, so Cluster API really boils down to a few kind of core concepts. Like mentioned, we are going to use Kubernetes to manage Kubernetes, so we need to have a thing called management cluster. So it's really a cluster where we extend the cluster functionality by utilizing custom resources, custom operators, and things like that to enable that cluster to actually manage other clusters. And the other clusters are called workload clusters. I often, and you might hear me talking about things called child clusters. Child cluster, workload cluster, same thing, different name. And I sometimes use a term called mothership cluster for the management cluster. I'm super into sci-fi stuff. As Kubernetes is very, very extensible, thus Cluster API is following similar patterns of being super extensible. So Cluster API can be extended with providers. There's a couple of different providers. I'll dive into those. And like I mentioned, everything is defined by custom resources. So custom resources will be your API and the contract, how you actually create and manage those other workload clusters. So Cluster API really, the kind of beauty of it is this extensibility. And the extensibility comes with these providers. Because early on, the Cluster API developers, they figured out that there's no way on earth we can build something that can actually manage all the different cloud providers, all the different types of infrastructure. It doesn't make any sense to build everything into one package. Like Kubernetes did at first. They built all the different cloud providers within Kubernetes code base, and it came pretty unmanageable. So there was a separation. They ripped out all the different storage providers for different cloud providers and those kind of things, and externalized them. Hid them kind of behind different interfaces like CSIs and CNIs and whatnot. Cluster API used those learnings and built things in a kind of pluggable way from day one. There's like 3 main types of providers. Infrastructure provider, well, as the name implies, it's responsible for talking to the specific infrastructure which you are using. OpenStack, Amazon, Google, bare metal even. Control plane provider, as the name implies, that's a provider responsible for figuring out how do we actually configure, how do we run the control plane for the workload clusters. And then a bootstrap provider, that's responsible of running and configuring the worker machines of those child clusters, workload clusters. And of course, there are different providers for each category. So you could use kubeadm to manage your or configure your control planes. You could use our stuff called Cosmotron, for example. And there's different providers for the worker machines as the bootstrap providers. One thing I probably should mention that the infrastructure and bootstrap provider, they have a contract between them. Because the infrastructure is basically telling that where do we run the machines? Where do we run the VMs? How do we boot up the VMs? But the bootstrap provider is actually telling that okay, once you got the VM up, what do we actually run on the VM? And the interface is Cloud Init. So essentially, the bootstrap provider creates a Cloud Init data which the infrastructure provider uses when it boots up the VM. We're going to dive into some of the main concepts and main custom resources, but a very, very common pattern in Cluster API is this abstraction model where Cluster API defines very abstract things like cluster. That doesn't really mean anything yet. So we have to also be able to tell that what kind of infrastructure we use for that cluster. So for me, personally, it's not really a correct way to interpret this. But for me, when it really clicked in my head was when I started to think about it like object-oriented way. So a cluster is kind of like an interface or a very abstract base class. And then the infrastructure cluster is kind of like an implementation of that interface or the abstract class. And this sort of pattern really repeats in many, many different places in Cluster API. If we think about a resource model for a typical simple cluster, we define a very, very high-level cluster object. Okay, that doesn't really tell anything yet. So, like mentioned, we need to kind of tell also that how do we implement the cluster with an infrastructure cluster object. That could be Amazon cluster, Google cluster, OpenStack cluster, bare metal cluster, whatever type of infrastructure you are using. A cluster needs a control plane, for sure, always. So we tell that, okay, for this cluster, we're going to use this sort of a control plane. And again, control plane is kind of an abstract, so we need to tell that, okay, in what infrastructure we are going to run the control plane, and in what kind of a configuration we want to run the control plane. If you are and have been using kubeadm, for example, your control plane configuration would be kubeadm configuration that you use anyway for when booting up things with kubeadm. When it comes to worker machines, Cluster API again has a very abstract notion of a machine. Doesn't really tell anything yet. So again, we need to hook it up with infrastructure-specific machine plus the bootstrap configuration for it, essentially cloud init. So this kind of an abstraction pattern repeats many, many times in Cluster API, and this sort of a references between different objects. You'll see in the actual examples soon. I mentioned a concept called machine. But if you think about how do you manage your existing Kubernetes workloads, your applications, you very, very rarely create any pods directly, right? I mean, yeah, you occasionally run things like kubectl run, nginx, yada, 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 which creates individual pods. But usually you use some of the higher level concepts like deployments or stateful sets or things like that. And exactly the same way, Cluster API has a concept called machine deployment. And as the name implies, it really works, I'd say, pretty much exactly the same way as a deployment worked for pods, but machine deployment works for machines. So it basically creates and manages a set of machines. You have a field called replicas, so you can say that, okay, I want to run 3 of these machines. And then if you want to update those machines with the newer version of Kubernetes, change some configuration or whatever, you re-roll a new version of those machines, like you do for pods as a rolling deployment. So conceptually, it's exactly the same, which is super, super cool. All right, let's look at some of real-life examples, or a real-life example. And yes, there's plenty of YAML involved, unfortunately, with Cluster API, but we're at KubeCon, so we're already all used to looking and writing a lot of YAML. So I'm defining first a cluster object. That's the kind of root of my graph of objects. In a cluster, I mean, it's a CRD, so you have the usual metadata and names and whatnot. And on a very high level, you can configure very, very high-level things like network addresses, CIDRs for ports and services, and so on. So it doesn't go really into any details yet. What we do is, in the cluster object, we tell that, okay, we are going to use this kind of a control plane, and we are going to run it on this kind of an infrastructure. So this abstraction and implementation pattern. For the control plane, depending on which provider you use, you give a lot more configuration for the control plane. And in this example, I'm using one of my team's providers, which is actually running the control plane as pods in the existing management cluster, which is another cool pattern that you can do with Cluster API, but let's not go there. And then in the infrastructure cluster, I'm using a provider called Hetzner in this example. You're defining the common infrastructure for the cluster. So if you could define like security groups and subnets and VPCs and common infrastructure, things like that. And of course, we need to configure some sort of a API token with which the provider can actually talk to the cloud provider API. And of course, the things that you can configure on the infrastructure providers depends heavily on the infrastructure you use. Of course, if I use a bare metal provider, I cannot go and configure VPCs and things like that. Probably, maybe I can. Machine deployment. So I want to run X number of worker nodes. In this example, only one. The usual pattern of a deployment. You have a spec, you have a template, you have a spec, and basically the two most important parts in that spec are references to the bootstrap configuration, telling what are we going to actually run on these machines, and then a reference to an infrastructure, where are we going to run these machines. Looking at the actual provider-specific machines, you configure like type of machine, telling how many CPUs, how much memory you're going to use, and those sort of things. In this example, I'm configuring to run Ubuntu 22. I specify which SSH key I want to use, and the usual things that you'd configure anyway when you boot up a machine on any provider. And again, what you can configure on this level depends on which provider you use. And then finally, the configuration, the bootstrap configuration for the machines that are about to be created, just for the sake of the example and not to drown you in a sea of YAML, I'm just telling that, okay, which version of Kubernetes I want to run on these worker nodes. You could, of course, depending on the provider, go and configure the hell out of kubelets and containers and whatnot. All right, so with this few line of YAML, we actually get a cluster at our hands, which is super cool, because now everything is declarative, simple-ish set of custom resources. But yeah, what about day two stuff? I mean, it's nice to get a cluster, but I want to be able to actually manage the cluster too. Cluster API does come with a lot of helper and helping functionality for day two problems too. So for example, everything is now a custom resource. So what if I want to upgrade my Kubernetes version? Well, you can go and just edit the custom resources. I mean, you probably shouldn't do kubectl edit, yada, 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 but you get the point. Cluster API internals also have some amount of controls to prevent you actually, for example, upgrading your worker nodes before you upgrade your control plane, because that would be a version skew mismatch. So it doesn't actually, if I try to update my machine deployments to a newer version than my control plane is, CAPI actually says that, sorry, no can do. I'm not going to do this until the control plane is updated, which is like super nice. And then, like I've been mentioning, everything is declarative, everything is set of custom resources. So you can actually start to orchestrate upgrade, for example, upgrades over multiple clusters. You can actually sequence those with some scripting, whatever tools you want to use. And then cluster templating helps actually here quite a lot. Cluster API, in its core, it has a concept called a cluster class. So think of a cluster class as kind of a set of golden custom resources that define a cluster. What you can do with cluster class is actually instantiate those set of golden custom resources to a cluster. Okay, I want to have another one of those kind of clusters, so I just instantiate another one. So that's a way you can kind of standardize, in a way, your clusters. So say you're a platform engineer, you create these cold and custom resources, and your developer teams can then request one of those kinds of clusters. So you get kind of like homogeneous set of clusters. The challenge with cluster class, to be honest, is that the parameterization, that's a difficult word, it's actually defined as JSON patch operations, which gets super tricky super quickly. In our current open source project, we use a similar concept called cluster template, where we actually use Helm style templating, which is, I'm not a fan of Helm templating, but it's much more approachable than JSON patch operations. And another way to standardize things, because again, everything is a custom resource, so you can use Kubernetes or other policy engines to actually apply a set of allowed policies. Which kinds of clusters your teams can actually create? What are they really allowed to be creating? Another important concept for operations is of course, health checking and remediation. Cluster API has a custom resource called machine health check. So basically, you can define that if this node, or if the set of nodes that this health check matches, if they are offline for, say, 10 minutes, kick them out of the cluster and create a new one. Just like you do with pods. If there's health checks failing, Kubernetes will go and kick those out and create new ones. So CAPI is really reusing the learnings and patterns from Kubernetes itself. OK, so we now have n+2 clusters at our hands. How the hell do we manage workloads on all of those clusters? Well, CAPI does actually have some concepts called the cluster resource set, yes, which you could actually use to deploy things on multiple clusters. Or you could go like GitOps all the way style, where every single workload cluster that you create actually pulls in configuration and applications using GitOps patterns. But that actually comes with a challenge, especially if you start to run like tens or hundreds or maybe thousands of clusters. You have 1,000 clusters to configure for GitOps. Whether that's a problem or not depends on your use case. There's also things in our current platform, and especially an open source project called Sveltos, which is super cool, which actually enables you to use the management cluster as a source of truth for applications running on the child clusters. And these are, of course, driven and configured by custom resources. So you could actually do like GitOps on the management cluster level, and that'll spread out the configuration for the child clusters. There's multiple different patterns how you can do this. All right. So Cluster API is a way to get declarative management, central place to manage your workload clusters, different providers, abstracting away the infrastructure, control plane, bootstrapping of worker nodes. Everything is a custom resource. And I'd say that mostly in a positive way. There are various ways of doing cluster kind of templating, which will help you, especially when you're building these platform engineering capabilities. And Cluster API, while being declarative, it really helps on day-to-day operations like upgrades and health checks and all that stuff. That was super, super quick dive into Cluster API. We only scratched the surface, but I hope that gets you kind of at least to a starting point and understand the mental model of it, and look up the Cluster API book and dive into it. Thank you.